Live from ATCE 2024, the Society of Petroleum Engineers presents SPE Tech Talk.
Hello, and welcome to the Energy Stream stage at ATCE 2024, located inside the exhibit hall of the Ernest N. Memorial Convention Center in New Orleans, Louisiana. Thank you for joining us for this live SPE Tech Talk with Halliburton. I'm your host for this broadcast, Adam Wilson. A successful well intervention will involve pipe recovery at some time throughout the life of the well. We're joined by our friends at Halliburton today to discuss the opportunities presented when moving to a safer and more efficient pipe severing solution by using electromechanical tools to cut pipe. Now, one great way to interact with today's broadcast is to let us know where you're watching from. If you have a question for today's expert, type it in the comments section on LinkedIn or Energy Stream, for a chance our guest will answer it during our Q&A segment. Before we begin today's live discussion here at ATCE, let's take a look at today's poll question. Okay, the question is, what is more important when cutting pipe? Low cost with a flared cut or safety and efficiency with a flare-free cut? Let us know your answers in the comments section on LinkedIn or Energy Stream, and we'll take a look at the results later in the show. Okay, let's get started and introduce our guest. Joining us today here on the Energy Stream stage at ATCE 2024 is Frank Heaney, wireline and perforating well intervention product champion at Halliburton. In his current role, Frank is responsible for the development of the Clear family of powered mechanical tools, which include ClearTrack wireline tractors, ClearCut electromechanical cutters, ClearShift high expansion selective shifters, and the Relay digital slickline portfolio. Frank joined Halliburton in 1990 as a wireline field professional working in the Gulf of Mexico and progressed to various technical, professional, and field management roles through his 33 years at various global locations. Before joining the Global Well Intervention Product Champion role, he led wireline and perforating in Angola as the business segment manager. Frank began his oil field career in 1981, working 9 years in Canada with computer logs, starting in the maintenance lab before advancing to project engineer and Arctic and overseas operations. Frank earned an electronic technology diploma from Salt Lake College and is a member of SPE. Hi, Frank, and welcome to SPE Tech Talk.
Oh, wow, thank you for that great introduction there, Adam.
Okay.
So you made me sound very old.
Oh, I'm sorry.
Which is probably okay for pipe recovery. So.
It's the experience that counts.
It is, it always is.
Well, let's begin today's discussion, if you could, by explaining to our audience, both here in person and watching online, why exploration and production operators need to be concerned during pipe recovery.
So I'm going to go with a fairly long-winded answer for this one, Adam.
Okay.
So I'm going to start with when I was a field engineer. Probably the most important question, the question I got the most was, how long are you going to be done before how long before you're done the task?
Right.
So generally I was a logging engineer, so when are you going to be done? When I became a field service manager, it was how many beds you're going to take up or what's the POB you're sending me. So that was a big deal. But then I became a desk engineer, and that's when I really started to put the whole gamut of what my business or what I did in this industry together. And so there I understood what the D&C group, and it was an orchestration of a lot of different things. And they had a lot of tasks that they had to get done. And what for me, it was that moment or that Covey moment to begin with the end in mind that I understood what I was supposed to do. And my job was, the big secret I tell my people is the secret of the oil and gas business is they sell oil and gas. And although it sounds, flippant, our job is to help them facilitate that operation quicker. And so what I saw was when they have unplanned events, people get really worried because they have so many things that basically butt up into each other. And so once I got that clear, it was really important that my goal was to help them in these really not desperate times, but times that are a little bit more challenging, that we give them a confident answer to how we're going to solve this problem. And so that's how I kind of got to there. So why it's important back to the question is we're going to give you a confident answer how to get that pipe out of the ground so you can get back onto your program.
So what are some of the challenges with that operator faces when they need to cut the pipe?
Well, I got maybe we'll put this slide up, and this is kind of how I look at the challenge, and that it's in no particular order, and it depending on where I might be in the world, certain things will be more important than other things. So if I'm in the Middle East, I generally have to look at an explosive escort. So that's generally a government person that's not necessarily oil field related, who works on government time. And when we have a pipe recovery, it's an unplanned event. And so people like to get things done a little bit quicker than maybe that is it. We have to look at the well itself. So the completion details. Can I get a tool down? Do I have some ID restrictions? What if I have very high hydrostatic? Is that going to be a problem? Do I have some challenges there? Maybe have some pipe details. Like we're really seeing a lot of the exotics, especially the CRA or corrosion resistant alloy pipes. Okay. And so we have to think about how do we manage that, because that might take a different device. Some pipes get very thick. Maybe I want to have a solution to cut heavyweight drill pipe. So what do I do there? We might have some other issues, special requests. So maybe I want to cut a flat pack that's on the back side of the pipe. So that's a bit of a challenge. So how do we manage that? Could be a number of other things. The other thing that's, it shows on the slide here is, although the schematic says all the pipe is perfectly centralized, the reality is it's not downhole. And so you have to be cognizant of the fact that you may be, one pipe might be right on top of the other pipe. So all those things kind of come into play. So that's how I look at it. That's my kind of way I look at my considerations to pipe recovery.
Boy, it sounds like there are a lot of facets to solving those problems.
There's no straight solution, and you're looking at everything, and different cutters will have different attributes, when we're looking at it, and there might be a budget constraint. So maybe they have to do it. They only have so much budget. The idea from my perspective, pipe recovery is let's do pipe recovery right the first time, so we move on with the program. If we're not doing it right the first time, it could make a more unplanned event, and then costs really start to escalate. So that's what our goal is, to do it right the first time.
Excellent. Well, before we go any further, before we continue on our discussion, let's take a pause and remind our viewers to get involved in the conversation. So you can type in any comment or question you have on today's topic now on Energy Stream or LinkedIn for a chance that Frank will answer it during our upcoming Q&A segment. Okay, Frank, let's get back to our discussion.
Okay.
So what are some of the advantages of working with electromechanical cutters, EMCs?
Okay, so again, I think we got a slide for this. And so I look at it this way. So one of the big challenges we see today is dangerous goods. So pipe recovery generally it could be a chemical. It could be a plasma type flammable solid, generally always involving something explosive. So a lot of times that's not necessarily conducive to being very HSE friendly.
Yeah. Right.
So that's one of the things we got to think about. A lot of times we want to do a flare-free cut. And the reason we want to do a flare-free cut is because something coming behind it, usually fishing of the pipe, if I have to go in there and dress it, if it's flared, that may take more time. So that is always a challenge, A lot of times we're talking, if I want to get down into the deeper parts of a drill pipe recovery operation on the drill bit, I might want to cut into the heavyweight. Can I cut into heavyweight? Heavyweight's a lot thicker than a regular drill pipe, which might be a fairly easy cut. But now we're talking something like an inch thick of pipe. Can I have a tool that's going to do that? High hydrostatic is a big problem. a lot of the tools don't do very good in hydrostatic. They actually have to go through that hydrostatic before that energy that's released from that tool will actually start cutting the pipe. So if you have something there, we do a lot of cut to release stuff with packers. I work in Singapore right now, right beside where HCT is. So we get to cut all their cut to release packers. So that's really interesting. So in that case, I can't really cut the second string of pipe, which would be the packer piston, because I would compromise that. So we got to be thinking about that. A lot of times we might be in a compression scenario. How do you manage compression? Some of the newer exotics like GRE or VIT type tubings, how do you manage those? Because they are kind of unique, you know, a lot of different things. You know, when we go into cutting flat packs or TC cables, we're now talking about cutting something on the outside of the pipe. So how do we manage something on the outside of the pipe when I got one tool that's only going to cut to the end of the pipe? So that's kind of one of those scenarios we have to think about. So we work on all those things. Could be some temperature issues. Like, you know, what if the temperature is really hot? Do we have the right solutions? So we might see things upwards in the 400 degree F temperature wise. So all those things come into play, and electromechanical tools can actually manage all of those quite successfully, where some of the other tools will be challenged. So.
Well, excellent. That's great. Sounds like there's a lot of advantages to it. And you mentioned all the different types of pipe that are that you're going to have to remove. Will one EMC tool cut all the different pipes, or is it flexible?
That's a great question, and there's lots of different attributes. So, as we said, a lot of it determines the ID of the actual pipe. What is my restriction? Can I get down there? And what is the OD of my tool? We can cut from electromechanical perspective. We're being asked to cut everything from 2 3/8 all the way up to 9 5/8. That's a big selection.
That's a wide range.
And so to manage that, we're able to do that, and we have different tools. And generally what we do is we swap out for different head sizes, depending on the application, to manage these different scenarios. So we do have some levers to pull, so that allows us to manage that task quite effectively without doing and adding a whole lot of extra additional costs to the well.
So that leads me to ask, so when you're designing an electromechanical cutter, what are some of the critical metrics that you're looking for?
Great question. And then I'll put up another slide here. And so again, I look at it kind of like this. So I start usually pipe thickness, but it may not be in this necessarily order depending on what I'm throwing at. But pipe thickness is a big challenge. That almost eliminates a lot of different type of cutters. So if I got a really thick pipe, I'm gonna have to pick on probably the electromechanical cutter. One of the things we see a lot today is these new exotic pipes. So API 5 CRA, which is corrosion resistant alloy pipe. Like, one of the requests we've been seeing lately is, you know, how do you manage SM2535, which is in its nature, it's 37% nickel and 27% chromium, which is a really, really difficult cut. It's not like cutting your typical carbon pipe. So it really takes a different type of tool to manage that. You know, we can make a machine shop quality cut downhole because we're actually physically putting a downhole lathe, or putting a lathe, machine shop lathe downhole. The parts that we use in our cutter are actually, we buy the inserts actually from the machine shop.
Oh, okay. Well, so
that's why we're able to do that. But in order to have a machine shop quality cut, you have to have all those parts of the lathe. So our chuck, or what holds the product in place, or the pipe in place, or whatever we're doing on a machine shop, that's our anchors. So really important, you know, I use this term, as low as reasonably achievable for vibration. So I stole one of my radiation acronyms to apply to vibration. So that really helps us out. Are we going to cut the second string of pipe? You know, on a cut to release packer, it's a big deal. On other pipes, it might not be a big deal, you know. So, you know, is the pipe in compression? Like, a lot of times we're cutting in between two packers, so the pipe will be in compression. How much compression? We wouldn't necessarily know because there's no gauge down there, but we know what happens in pipe compression, and so we manage it. TC or flat packs is a big deal. You're having to cut beyond that OD of that pipe, so we have to come up with a different solution, and that's our rotary blade type device. So as opposed to a single blade device. So, And a lot of times debris is a big deal. Some customers don't want a lot of debris. Some pipe cutting is fairly aggressive, just like in the machine shop. So they want to lower debris. So we can manage that by reducing our feed rate and managing that aspect. So a lot of different aspects and a lot of different levers that we pull on.
That's fantastic. That's a lot of great information. Thank you for that. Well, now before we go on, let's take a quick look at the results of the poll question we asked our audience. So we asked, what's more important when cutting pipe, low cost with a flared cut or safety and efficiency with a flare-free cut? And it looks like the majority of our audience chose B, safety and efficiency with a flare-free cut.
And that's pretty much in line a lot what I'm seeing. People are trying to move away from the dangerous goods part of our business. There's a lot of reasons for it, and it's obviously a KPI within the organization to become a safer. And the only way you're going to do that is to move away from some of the dangerous goods or dangerous chemicals or explosives. So that's one of the things that we were able to do with the electromechanical cutters.
And you mentioned earlier the advantages of having the flare-free.
Definitely from a perspective of being much more efficient. And it starts from the very beginning when I said, our job or my job is to facilitate finding oil and gas at a more efficient way. And how do we do that is to find the best way to do that. And so electromechanical cuts have those attributes that really hit those key decision points that any operator would want to have on their side. So
Excellent.
That's why we work with those.
That's great. Well, now it's time to see if we can take some questions from our audience and see if we have any of those for you to answer. Let's see. So can you outline 3 examples where an EMC cutter will improve well site efficiency?
So sure. So let's take a look at, we're going out and we'll take the Middle East because I do a lot of work in the Middle East.
Okay.
So we're stuck there, or we've got the pipe stuck. Let's say in this case, the rig stuck. So the rig can't do anything. So they call up, we're stuck, can you help us? The first day, if we took out explosives, which is a typical solution, I'm going to have to get an explosive escort. So that's not really that great. So a drill pipe scenario, like I have 3 rules of pipe recovery. First, in order to get the pipe at the ground, the pipe has to be free. So that's rule number 1. Rule number 2, the cutter needs to be centralized. So if the cutter is not centralized, because you're cutting 360 degrees, so you got to make sure that you are centralized. And rule number 3, the cutter can't move. So from a perspective of number 1, the pipe must be free. I can run the electromechanical tools with the Free Point tool. So I can tell you where the pipe is free. So I'm only going to make the 1 cut in the free pipe. So that gives that really helps us along the way. Another example is, so we've improved our HSE. We're going to make 1 cut in the thing, and we're actually going to make that cut in 5 minutes, which is really quite helpful. So we've given you a very clear solution to a rather difficult problem, which is an unplanned event, which is put people at edge because, that wasn't what they were planning to do. And they got a lot of other people coming along in the process to manage this task.
And the quicker you can fix it, the better, right?
There's that the fact, as most people would say, the best pipe recovery is the one I didn't have. But if I'm going to have one, I'm going to have an event, let's make it as quickly as possible and as clean as possible and as seamless as possible without adding any more risk to our environment. And so we don't have any explosives. We don't have any dangerous goods. So we clean that part up.
Excellent. Well, so our next question has to do with fluids. A viewer asks, can you cut in calcium chloride, calcium bromide completion fluid brines?
Absolutely. We can cut in, from an electromechanical perspective, we can cut in any fluid. It really doesn't matter for us. Where some of the other cutters, they can't manage those different fluids, especially the bromide fluids. They will react to that if they're a chemical process. We don't have that scenario. It's just an electromechanical process. It's just we're just taking a blade. Think of a machine shop and cutting a piece of pipe in a machine shop. So none of that really falls into play for us. Great advantage. And then the same thing with the hydrostatic, and not having to overcome any hydrostatic pressure before my energy hits the pipe to cut it. I don't have a problem with hydrostatics. So it allows us to go to a lot higher hydrostatic.
Yeah, and another question here is about paraffin.
So paraffin, like that would basically absorb some of the energy and wouldn't allow you to cut, where we'll just chop through the paraffin. So one of the big things we see today is GRE, which is glass reinforced epoxy pipe. So that has got a layer of fiberglass, a layer of mortar, and then you have the actual steel pipe beyond that. Some of those cutters, all that energy would be absorbed into that mortar. It would never have enough energy to actually break the pipe or shear the pipe.
Okay.
In this case, we're just going to cut through all of that. And we've done that a number of times, well in excess of 10 times, very, very successfully, and it works quite well.
Excellent.
So
excellent. Here we have another question from Energy Stream by M. Aid. Wants to know, what are the different types of EM cutters Halliburton offers?
So Halliburton actually has 3 different cutters in the EM family. So we have what we call a single blade cutter. So that's kind of our generic tool that does a lot of the different cutting. It'll cut from 3.5 all the way up to 9 5/8. So big, broad spectrum of cutting. It'll cut to the end of the pipe. Great for cut to release packers. Very good solution for stuck drill pipe. It will cut heavyweight. Our second tool would be our rotary blade cutter, and that's how we're going to manage to cut basically those flat packs or those pieces of or TEC cables, tubing encapsulated cables that are riding on the backside. Now we able to extend out very far, so we can actually make that cut, and even if that flat pack was offset a little bit, we can still manage it and we still cut it. We can set that cutter up into either a sweeping motion or a plunging motion, so we can manage that. And then we have our newest cutter that we're introducing this year is our slim cutter. So 1/11/16. It's a battery operated tool. It works on our digital slickline platform. Okay. And we're basically cutting the very small stuff from 2 3/8 up to 3.5 with a 1/11/16 tool, which is quite amazing because that's a very small tool to manage that, and we're still doing electromechanically.
Right. So rather than use, a hammer to kill a fly,
correct,
right, you're going to get the right tool.
You got the right tool.
job.
So we're able to run that gamut from 2 3/8 all the way up to 9 5/8 and manage those other things that are a little bit more difficult, such as the offset flat packs. How do you manage that? And we have solutions for all of them.
Excellent. You mentioned earlier, here's another question. You mentioned maybe high temperatures are an issue. And here's a question. Can you cut in pressures up to 30,000 PSI?
Absolutely. We're actually doing that project right now. And so we're putting that together, and we'll be doing some testing here in the coming months to 30,000. This one would be 300 degrees F, but we have no problem going to 400 degrees F. With the cutter. Like the cutter itself, the motor will definitely take it. The electronics is what we generally just put those behind a thermal flask. Like the process of cutting is so quick. Like generally, depending on what I'm doing, 5 minutes for a single blade cutter. For a rotary blade cutter, we might be talking about 45 minutes. It's a little longer because we're cutting a little less cut every rotation, but still not a tremendous amount of time. And a thermal flask will give us like 4 or 5 hours. And we're never down at that hot temperature for that long. So we're able to manage that quite well.
Excellent. So speaking of pressures, here's another question. Can you cut without making a weep hole to equalize the tubing and annulus?
Absolutely. So as I said, think of our operation like a machine shop on our lathe. That chuck is our anchors.
Okay.
We can't move. So we use actually... In the single blade cutter, we have 5 different anchors. On the rotary blade cutter, we have 2 different anchors. On the slim cutter, we have 3 different anchors. And all of that is to basically keep everything stationary. Just like a chuck would keep your product in your lathe stationary, that we're doing exactly the same thing there. So we don't have to do that. We're going to stay stationary. Now, other devices out there that cut pipe, they basically take about a second to 2 seconds to do. In that process, if you did not have that weep hole, you would actually be the difference in pipe between your annulus and your tubing would be enough to move the cutter, and you wouldn't make the cut. In our situation, not a worry. The anchors will
Because of
keep
those
everything in
anchors.
stationary. So that was one of the kind of design criteria from our tool.
And another viewer wants to know if you can cut shallow where there's no hydrostatic head.
Absolutely.
All
So
right.
that's a really big challenge, because a lot of cutters demand to have a certain amount of hydrostatic so that the cutter wouldn't move. Because the anchoring system's so good, and because we spent a lot of time thinking about the anchoring, we're not going to move. So even if I was to cut, like we've made very successful cuts at 200 meters, but we could go at 30 foot and still make that cut quite successfully.
And again, it's the anchors that
It's the anchors. So always think about it and build backwards to the process. What are you doing? The design is, it's a lathe, so let's make it look like a lathe. That anchoring is as equal as important as that cutting insert. And so that's how we look at our problem.
that's great. Frank, we really appreciate you joining us for today's live SPE Tech Talk here at ATCE 2024 on innovative pipe recovery solutions with electromechanical cutters.
Well, thank you so much for the time, and I very much appreciate the talk, Adam.
Yeah, how can people get in contact with you if they want to learn more?
Well, I'm on LinkedIn, and I'm also on anything frank.heaney@halliburton.com always works too.
Excellent.
So
Yeah.
both places, and I'm able to answer any more of the questions. And like I said, done a lot of different pipe recovery operations and involved a lot of different types. So
Yep.
I'm very confident I can give you a very effective solution.
Excellent. And certainly you have Halliburton has its booth right over there at ATCE.
We do, and so I will be here for the week. So
yeah,
come
so-
and visit me, and we can talk about that or a lot of other tools.
Thanks again, Frank. And special thanks to Halliburton for their support at ATCE 2024 here in New Orleans. You can watch a replay of this episode on the SPE Energy Stream, the industry's digital pulse. Visit streaming.spe.org. I'm your host, Adam Wilson. Join us again next time right here on SPE Tech Talk.
Don't miss a moment of any of the great SPE LinkedIn Live events. From the event page, click Attend and Add to Calendar for notification reminders when an SPE LinkedIn Live event is ready to begin. SPE Lives, Tech Talks, Get to Know series, and more. Remember, click Attend on LinkedIn.
In a rapidly evolving energy industry, you need to stay ahead of the curve with relevant content available when and where it's convenient for you. You need the upgraded SPE Energy Stream, the global platform for high-quality content with the energy industry. Fuel your energy career with Energy Stream's sleek new look and easy access to top-quality technical solutions, insights and innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event highlights, this exciting, easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders. Then save the videos that interest you and watch them at your convenience. Be at the forefront of energy knowledge and explore the newly updated SPE Energy Stream now.
Live from ATCE 2024, the Society of Petroleum Engineers presents SPE Tech Talk.